I think I want to weigh in on this whole issue of computer studies in our curriculum and the way we are teaching it or not teaching it. After the rationalization of the curriculum in 2024, a lot of things were cut out, and computer studies in particular in grade 7, 8, 9 was more or less cut off, and it was supposedly put in pre-technical. So, and I've opened here the pre-technical studies curriculum just to see how they put it in it. And in grade 7, there's computer concepts, definitions of computers, definition of data, information, and things like those. Then hardware, just the, all the various devices, and then how to use things like email, video conferencing tool, etc. And then the ethical side of things, safety, cybersecurity, etc. That's grade 7. Then moving on to grade 8, they go to visual programming. So visual programming is learners being introduced to the concepts of coding through applications like Scratch and such things. Then again, computer hardware, just a bit more, computer software, functions of software, how software works. So really just the theory of computer science. And then again, the ethical stuff, data safety and security. And then finally, grade 9, again, a continuation with visual programming. And then app development, which looks really good as a title, but it's more of learners to develop interactive stories, games, and animations using visual programming tools. And e-government services. So with this kind of curriculum, it's sort of okay according to me, but I think it's desperately shallow, especially for the intentions for which we want out of computer studies. Computer studies, the purpose of it is really to, of course, develop people who are literate digitally and also people who are able to apply, to use it. But then a very big purpose is also to prepare the next set of power users or innovators around technology. And with this kind of curriculum, we are not doing enough to prepare these people. By the time they're going into grade 10, these kids are what, 14 years maybe? They should have, and they have the capacity to really do way, way, way more than this. And I am saying this especially for schools that already have computer labs, already have access to computers, already have teachers. I think it's such a waste of resources to only teach this kind of a curriculum. And I guess that's why schools do offer a complementary or a supplementary computer studies program or computer lessons that supplements what is in pre-technical studies. So next, I want us to look at these supplementary programs, these computer studies or computer lessons programs, and how they look like. So once again, prior to the rationalization of the curriculum in 2024, there seemed to have been a reasonably good set of content and syllabus for computer studies or for teaching the various computer lessons in the schools. And there was a curriculum from grade 1 all the way to grade 8, I think, by the time the rationalization was happening. And there were even textbooks that are out there, and actually they're still out there, to be fair. Now, if you look at that curriculum that those textbooks are based on, you'll realize that, first of all, there's no curriculum for preschool at all. But then we have grade 1 and 3, which is terminology, understanding the various devices, all those things, and just that normal thing of not having phobia around computers. Then grade 4 to 5 was the various software tools, understanding internet safety, word processing, file management, things like those. Then grade 6, spreadsheets, so Excel, and presentations, so PowerPoint, and data handling here, and then digital art, using the computers and these tools to be able to produce some kind of art. And then finally, grade 7 to 8, there are some aspects of robotics and some aspects of programming that were there. So I think that curriculum was, pretty substantial and solid, and it had quite a lot that it could do. To be fair, some schools are still implementing this curriculum, and to me, I think there's really nothing wrong with this curriculum, and it's certainly better to have this than to only offer it during pre-technical studies, because this year can genuinely get your kids better prepared for life as power users or people who will eventually be professionals in that sector. And this is a sector we need to overproduce for. We really need way more people entering this sector, having these capabilities, because whether it's engineering or medicine or sports or virtually any other field, it's going to rely on people who have very advanced computer science or computing skills. So that's why I really think that having this kind of curriculum is a good thing. But then I still think this curriculum is insufficient. And if you look around what's happening across the world and you look around how other people are implementing it, there are even people with standards for how computing and computer studies and computer science and digital literacy, which are not really the same terms, should be done. There are standards across the world. So in the next part of this, I want to show you how these standards can be mapped to our curriculum, so that if we are teaching computer studies in our schools, we really can aim to develop people who are extremely competent and extremely capable. So when it comes to teaching computer studies and computer science and digital literacy and computing generally, there are several standards across the world, and some of them I've written here on the screen for you to be able to see and to research on further, and to sort of imagine a future where we design a curriculum for our system that sort of matches some of these international standards. I'm referencing these international standards not because they're necessarily good, because they're international, but I'm saying we have the capacity as Kenyans to be able to implement this in our schools, and our children are more than capable of being able to be taught this way and to absorb the material this way. So we've taken the trouble to look at these international standards and attempt to map them out to our curriculum, to our format and setup of schools, comparing with what other people are doing across the world. So I'll start from preschool, going all the way up to grade 9, so which is K to 9, kindergarten to grade 9. And how could it look like? So at the preschool level, you might wonder, what's the point of teaching these kids anything to do with computing? And you're right, the goal is not really to get them to own computers and laptops like this. No. The goal is for them to use what we call unplugged activities. So unplugged means no need for a device. Unplugged, okay? No need for a device. So it can be things like arranging picture cards, things like them arranging, understanding sequences. Like when you wake up in the morning, what do? I wash my face, I brush my teeth, I have breakfast, I go to school. I know they're doing that in the other learning areas, but here we are starting to develop in them some concepts, the concepts of logic, sequencing, and all that. It starts from here. And then for the computing side, if it's, let's say, PP1, preschool, the first level of preschool, it can be distinguishing between toys and tools, for them to know this is a tool and not a toy, and something else is a toy and not necessarily a tool. That can be the idea. PP2, we can start seeing whether they can identify patterns. And again, this matches whatever is happening in PP2. So like red, blue, red, blue, red, blue, that kind of pattern matching, and then grouping things by attribute. These ones are shoes, these ones are plates, such things. All this is actually very foundational. It's exactly what happens in computing. Now, if I go to grade 1 with this, for grade 1, we move into, they're better developed, especially with their psychomotor skills, how they use their hands and all that. 200 typing, like them being able to start using keyboards, them being able to use a mouse a bit here and there. That's really not a bad time to start developing some of the skills. And then more on the cognitive side, they can start, using, we can start having digital abstractions of what they were doing physically. So like they can look at something on a screen, which they would have done physically. They can look at something on a screen, like move right. Like they're able to understand that on the screen, like move right. Because during PP1 and PP2, we really focused on those things in the real world. Cardinality, I think, is what it's normally called. Grade 2, they can do things like, wait, repeat. So that's a bit of programming. Sequencing, like if you have this character of a toy, it can go up to here, it can wait, it can repeat an action like jumping and all that. We do this in our visual programming and Scratch programming. It's done all over the place. And slowly by slowly, these kids start getting some concepts more. Grade 3, file management, using the internet, and again, understanding things like loops and how to use loops. Loops are repeating things like, move forward, move forward, move forward, repeating things like those. So grade 3 is not a bad time. They're 8 years old. They can figure out so many things that are there. By grade 4, they can start understanding presentation software, and we really can push them to start applying, like use Canva to create a presentation about a book that you're reading. So something like that. Search, the concepts of search can be clearer for them. They can understand how to search for information better. I think many of them, and you know it from your kids, they're already very comfortable from some of these ages to be able to use search. And then being able to create interactive stories now using these visual programming tools. So because their brains are better developed for that kind of thing. In fact, they've started writing things like compositions. So their capacity to create things that are more creative is possible. Grade 5, we're talking about spreadsheets, so Excel and tools like those, and calculations. So again, done in a way that is very age appropriate, and digital skills like AutoSum and all those things. Same thing also with conditions, like if this, then this, or else that. So you see, those are the programming skills which come much, much later in this other curriculum where we are not bringing these things early for the kids. Yeah. So somebody might say it's too early for them, but I don't know. To me, I think this is more than the right age for this. Grade 6, graphic design, variables, encoding, and AI, a bit of AI. So we can start AI literacy. They can understand how AI works, how we train the systems to understand things so that the artificial intelligence can work. I think this is a time, and I think bringing in AI literacy is a very critical thing because of where we are in the world right now. Grade 7, they can now, understand now computer systems a bit better. You see, somebody might say identifying parts of a computer, like this is a RAM, this is a CPU, is a grade 1 work, but then it's too abstract also. They can identify there's a computer, but by grade 7 or thereabouts is when a child might have the capacity to be able to process. And to be fair, the grade 7 in pre-technical studies is actually here as well. It like brings in these concepts around this grade 7 stage. So I think that's the time. Then logic also. So formalizing logic a bit more before code. You see, sometimes we focus so much on coding, and really forget that logic and the ability to think matters way more than remembering code and syntax. Matters way more. So this is a part to do this, and then they can also do data analysis, simple data analysis. Like if people are above 50%, then they've passed. Or if people are between this and this, then they're exceeding expectations. If people are between this and this, then they are meeting expectations. That's analysis of data, which is a very good thing at this age for them to do. And I even think exciting for them. Grade 8, no problem in introducing some programming skills now and programming languages. Python is a really good one, where they sort of can start developing some things. Web development, using things like HTML, which is a standard or a language used to develop web pages, and CSS for styling of this. No harm in them being able to develop such things in grade 8. And then also understanding how computer networks work. Again, I think their brains are very much ready for this kind of thing. And then finally, grade 9. And for grade 9, again, they can focus now on databases, the concept of a database, which as a country, I really feel we made a mistake if I remember the 844 curriculum that was there, and the kind of projects people used to do 20 years ago in computer science and what people are doing right now. I think there's a big gulf in skill, and we are requiring a lot less from them. And we are especially afraid of databases. I know it's it's a bit of a challenging area to teach, but I think the bigger challenge we might have as a country is the ability of our teachers to deliver on this, other than this being a concept that our children cannot understand. I think they can understand, especially if presented to them, and especially if they've had the background that I've just talked about. with this kind of background, you really can have people who are capable of this. Yeah, so, and then they can create a project in grade 9. So I think if you're a school or a person who really thinks along these lines, that the purpose of teaching computer science or computing or computer studies is to develop very capable learners in this field, then I think this is the kind of curriculum that we need to implement. Of course, it's very reliant on us doing it cumulatively across the stages. But what I'm urging or what I'm saying is we shouldn't limit it and we shouldn't go for a very basic curriculum for these kids. I think they are capable of way, way more. And we give them a very good chance of success when they enter grade 10 onwards. By the time they're going to university, they can compete anywhere globally because of the kind of development that we will have done. So this is an area where we can put in a lot more rigor as a country.
The CBC app simplifies work for teachers and school administrators. Better teachers, better schools, brighter futures.